In this example, we're going to look at the Pareto distribution with k known, as we've written it here. And we want to find the maximum likelihood estimator for alpha. And we've got some constraints here, but we're going to set out and do the maximum likelihood estimation in the traditional way. So maximum likelihood, so we write down our likelihood. So the likelihood of alpha, given our data xn, is the product from I equals 1 to n of alpha times k to the alpha over xi to the alpha plus 1. These bits don't depend on I, so we can take them outside the product and we say it's alpha to the n, k to the n alpha times the product from I equals 1 to n of xi to the power of minus alpha plus 1. So that's just rewriting what we already have here. And then we get the log likelihood. Because it's much easier to maximize the log likelihood in a lot of situations. So the natural log of L of the likelihood function equals L of alpha equals n natural log of alpha plus n alpha times the natural log of k, which is a constant, remember. And then we're going to bring in our minus alpha plus 1 times the natural log of the product of I equals 1 to n xi. And we'll worry about that bit later. Then we get our DL. We maximize it with respect to alpha. So that is n over alpha plus n, the natural log of k, and then minus the natural log of that product of I equals 1 to n xi. And we can simplify that by writing it's n over alpha plus n, the natural log of k, minus the sum from I equals 1 to n, the natural log of xi. Applying the rule that the natural log of a times b is the natural log of a plus the natural log of b. Then we equate to 0. And remember, when we equate to 0, we put hats on things. So we say, so DL d alpha equals 0 implies n over alpha hat plus n, the natural log of k, minus the sum of I equals 1 to n, the natural log of xi equals 0. We want to solve for alpha. So we start by solving for n over alpha equals the sum from I equals 1 to n, the natural log of xi minus n, the natural log of k. Divide through by n, get 1 over alpha hat is equal to the sum, the natural log of xi, with 1 to n, minus n, the natural log of k, divided by n. Now you could go, I'll make this easier and I'll simplify and I'll divide through by n. But because you have this in terms of 1 over alpha here, you need to invert it anyway, so there's no point. So we get alpha hat here equal to n over the sum from I equals 1 to n, the natural log of xi, minus n, the natural log of k, where k is your known constant. And that is how to find the maximum likelihood estimator of a Pareto distribution where k is known, as we